Hello students, welcome back again. In this video, we're solving an example based on beta and gamma function. That is, these are the improper integrals. It's very easy and simple example, student. So we need to convert in terms of a gamma function. Okay. So what is a gamma function? First form, gamma of n is equal to integral runs from 0 to infinity e raised to minus x into x raised to n minus 1 into dx. This is first form. There is another form, gamma of n is equal to two types of integral runs from 0 to infinity e raised to minus x square into x raised to 2n minus 1 into dx. So students, we are using the first form here. Let's look at carefully. So let us take LHS. What is LHS I have or we have? That is here x runs from 0 to 1, x raised to m into log of 1 by x whole raised to n into dx. So what I am going to do is I am going to substitute the logarithm here, student. Substitute log of 1 by x. Actually, it is base e, student. You can remember, is equal to some other variable t, student. So now if logarithm goes to right side, it will become an exponential, student. 1 by x is equal to, it will become e raised to t. And you can cross multiply here. You will get x is equal to 1 by e raised to t. Okay. Or that is x is equal to, which is e raised to minus t, student. E raised to t goes to numerator, will become e raised to minus t. Whenever you are doing a substitution, we need to differentiate this. Differentiation of this is dx is equal to e raised to minus t. Differentiation is minus e raised to minus t into dt. And also we need to substitute, student, that is if x equal to 0, if x equal to 0, it is 1 by 0, student. So 1 by 0 means this is log of 1 by 0 is infinity is equal to t. So what is the value of t? T becomes infinity, student. So log of infinity is again infinity. When x equal to 0, t value is infinity, and when x equal to 1, this is a log of 1 by 1. Log of 1 by 1 is 1 is equal to t. Log 1 is 0. So t value is 0, student. So therefore, the given integral becomes LHS is equal to, given integral becomes integral t runs from x equal to 0, t value is infinity, student. Infinity to 0, x value is taken as e raised to minus t. This x value is e raised to minus t whole raised to m into log of 1 by x is equal to t. This will become t raised to n. What is dx? Dx is minus e raised minus t into dt, student. Okay. Fine. Further, student, this can be also written as, you can observe carefully. So I am going to take minus sign outside here, and the t runs from infinity to 0. So this is e raised to minus t whole raised to m is e raised to minus mt, student. So that is, as usual, we know a raised to m whole raised to n becomes a raised to mn, laws of indices. So into e raised to minus t into e raised to n into dt. Student, we also have an integral that is in minus times of b to a f of x dx can be written as a to b f of x dx. So here minus can be written in the reverse order, that is 0 to infinity. He runs from 0 to infinity. Here one bases are same, powers are added. So here you can observe e raised to minus mt minus t. So here I am going to take minus t common. You will get m plus 1 student. So this is e raised to minus m plus 1 into t into t raised to n into dt. Fine. Further, look at carefully. Since we know that the power of exponential is a minus x, or you can also observe this is x power should be linear. Okay, x power is 1. So in this, you can observe carefully. Here the coefficient or here the exponential power containing m plus 1 as well as t student. So I need to, so it is of course it's a linear, but I need to convert this. Okay. So how do you convert this? Again, once again you can substitute student. M plus 1 times of t can be substituted back into x student. Okay. So what will happen? By differentiating, you will get m plus 1 times of t becomes dt, x becomes dx. So what is the value of dt students? Dt becomes, you cross multiply, is 1 plus m into dx, or m plus 1 or 1 plus m into dx. Also change the limits. Okay. Also, when t equal to 0, what will happen? When t is equal to 0, 0 into m plus 1 is 0, then x becomes 0. When t equal to infinity, x becomes again infinity. Students, infinity like a ocean. Okay, you can add the water, subtract the water, you can multiply the water. Okay, it will remains ocean only. So for that purpose, it will become infinity. So now, which is equal to, so now new values, again x runs from 0 to infinity. So this is e raised to minus x, because m plus 1 into t is x. So what is the value of t here? T becomes, student, what is the value of t here? T becomes x by m plus 1. Let's multiply this. So this is x by m plus 1 whole raised to n into d. T value is 1 by m plus 1 into dx. Further, which is equal to integral x runs from 0 to infinity. Okay. This is e raised to minus x. To separate it, the student, x raised to n divided by, this is m plus 1 whole raised to n into 1 by m plus 1 to dx. Here m plus 1 whole raised to n and m plus 1 are constant. When again here base are same, powers are added, you can take it. This is 1 by m plus 1 whole raised to n outside, student. So what is remaining? The remaining is x runs from 0 to infinity, e raised to minus x into x raised to n, student, into dx. So as you know the definition of gamma function, gamma of n is equal to integral runs from 0 to infinity, e raised to minus x into x raised to n minus 1 into dx, student. So now in this, you need to substitute n by n plus 1 and observe what will happen. So this will become 0 to infinity, it will never change. N is replaced by n plus 1 minus 1 is just x raised to n into dx, student. You can replace this total integral by gamma of n plus 1. So which is equal to 1 by m plus 1 whole raised to, this is actually n plus 1, student, n plus 1 into, this is gamma of n plus 1 to gamma of n plus 1. Okay. Finally, we know that, student, one more property, that is gamma of n plus 1 is equal to n factorial. Therefore, it will become n factorial divided by m plus 1 whole raised to n plus 1, student. So that's it. Okay. We'll meet in the next video. Thank you so much for watching.